Welcome. This is video 3 from chapter 3. The topic of this video is input checking, input validation, and logical operators. We'll begin by concluding the previous video and talking about different forms of an if statement. We have seen a plain if statement with only a consequence. We've seen an if-else statement with one consequence, one alternative. We've seen the chain of if statements: if, else if, else if, else. And there's another form of an if statement called a nested if. And here's an example. Notice that in this construct we have an if statement and it has a consequence. The consequence right here is another if statement directly. So it's an if statement followed by an if statement. We call these a nested if. Notice that in order to reach this statement here, two things have to be true. I must enter the consequence by this condition. I must verify the consequence by this. So two things have to be true. Score has to be less than 0, and also score must be greater than 90. Whenever you have a nested if, you have to be careful about the else's if they appear. And the rule is an else matches the nearest active if that does not have an else. So here we have an if. This if is open. We haven't reached the end yet. We have another if. So from this point on, this if is active. So we have two active ifs. Here's the consequence of the second. Else, therefore, it becomes a consequence of the second if, this if here. Right? Sometimes, most of the time, proper indentation helps you comprehend what's going on. The indentation doesn't cause it, but it helps you to understand the grouping. Now let's do something very practical. We said in class that if we open a file, we need to make sure that we indeed have opened the file and have access to the data. Otherwise, we have seen that you have no warning, and your program will proceed and attempt to read from a file, but all you will be getting is garbage. The function that we want to use is the .fail function. We have seen that I/O streams have a lot of functions. We have the get line, we have the CIN, the .ignore function. We have a bunch of functions. One that is most useful is the .fail function, and it basically says, did the last input-output operation you attempted, did it succeed or fail? So here's the code. Let's read it real quickly. We're declaring an input file stream called data file. We're going to attempt to open it, and now our goal is to terminate the program if we are unable to open the file. So to determine whether it failed, we use the .fail function associated with the stream data file. If it returns a Boolean value, true or false. If it's true, it means bad things happen. Our consequence is to print out a message. You should always do that. And then we terminate the program. The exit function, you pass it a value that is non-zero, it's positive value, and it says let's terminate the program. Okay? So if we run this and cannot find a file called MyData, we expect the program to print out this message and stop. Otherwise, we expect it to print out the message done. So let's pull this up as a program, and let me show you. We have in this directory a file called MyData. So there is a file called MyData. And so when we compile this and run it, we expect there to be a file. So let's compile it. And let's run it. And it did not terminate. Let's get rid of this file, my data, and move it to another thing called my data. We have a file named my data with a capital M, not a lowercase m. So when we run the program again, we expect it to terminate with the error message that we have. All right? From this point on, in all of your programs, this is a standard part of your program. Every time you attempt to open a file, follow it up by a check to see if it failed, and terminate the program if it did. Another use of this is to see if any kind of read operation succeeded. So here's an example. We want to read 3 values, an int, a float, and a char. So we will attempt to read them one at a time. And to be successful, I must obtain a value for A, a value for B, and a value for C. If I'm unable to obtain all 3 of these values, this operation has failed. So we can test for failure. Notice that this time the fail function applies to whatever the stream you're using to get your data. In this case, it's cin, not an input file stream. So we can say cin.fail and print out a message. You might say, what should come next? Well, if we're trying to read from a file, we said we could terminate the program because there's no hope. If you're getting input from a user, what's other things you can do? Well, you can certainly try again. So here's a sample code for how you might try again. This is the initial read. If it fails, we'll make another attempt to read. All right? We will see later on that there is a standard way to handle failed input where you attempt to read it over and over again until you're successful. More on that later. Now, let's talk about validating inputs. If you're to ask someone's age, nobody should put in a negative number, or it should not say 1,000. So there's a range of values that define what's good. There may be other criteria that define good data. Some instances you're supposed to enter positive numbers, so anything negative is not acceptable data, and so on. So input validation is the process of inspecting input data to determine if it's acceptable. And of course, we have to make a decision about that. So here's an example of checking for age based on a range. So if we say ages should be between 0 and 120, when we read an age, we must check for it. And what we're checking for is not so much the valid age, but the invalid age. Invalid means either age is outside of the range on the left side, that is less than 0, or outside of the range on the right side, which is greater than 120. So the test for invalid age is either age is less than 0, the 2 vertical bars mean or the age is greater than 120. If that's the case, we will output a message saying you have an invalid age. There are times when you also want to check if something is inside the range. And the way you check for inside of the range, then 2 things have to be true. The value has to be greater than or equal to 0, and also it has to be less than or equal to 120. All right, I have this all wrong. This is wrong. Let's just say less than or equal to 120. All right? Now, notice that I just used something that we use all the time. We always say this is true or that is true, or we might say this must be true and this must be true. Notice that these conditions don't consist of a single comparison. It consists of 1 comparison, 2 comparisons, and a combining of the result. This is called a compound condition. If you say or, it means one of these conditions, either the one on the left or the one on the right, has to be true. If I say and, it says both conditions must be true. All right? In math, we can say the second one as age 1 less than or equal to age less than or equal to 120. We can say that in math, but we can't say it here. We must give two relational expressions. One relational expression, two. And both of those expressions must involve a variable. Okay. So I think we're going to stop here. We've kind of reached the time limit. Our next, we'll talk about logical operators. We just introduced them, and you've seen them before. We will go into more detail about the nature